Hi everyone, I'm Emily and I'm here with Ashley and we're the Engineering Chicks. And today we're going to talk about a procedure that we've created based off of some Maple code in MATLAB. So this is kind of a fail procedure and we're basically checking out the probability of survival for a specific component. And so some key things to point out here. This code is going to return a matrix C, and it has k rows and q plus 2 columns, and that's kind of indicated in our code. And the important thing to note is that in the first three columns, column 1 represents the probability for survival to 1,000 hours. Column 2 represents the probability of survival to 2,000 hours, and column 3 represents the probability of survival to 3,000 hours. And so another thing to point out is that the posterity density should reflect the prior density more so, with the results that the acceptance probability becomes higher and successive alpha and beta values are less correlated than the previous once it goes through those iterations. So that's kind of the base of what the code's doing right now, and that basically it reduces the variance of the estimators. And so Ashley's going to go through and talk about the results that we have.
Okay, so here we start with the values that we were given in the book. So we have values for K, A, B, N, and then these are X values. So this is our failure data. And then this is what Emily was talking about with setting up your columns here, the survivor probabilities. So first we go through, we compute the log likelihood for your first point, so your current one. And then we come down here and we create a candidate point, and then we calculate the log likelihood for that point. Here, this is our prior belief about the alpha density, and then the prior belief about the beta density. And then here's calculating the log likelihood of the candidate point. And then right here is our acceptance criteria. So we decide right here whether we're going to accept or reject the candidate point. And then if we accept it, we keep that survivor probability in alpha and beta, and we store that in C. So here, we're going to come down here. There's three of these that we're going to show you. So the first is going to be the survivor probability of 3,000 hours. Go ahead and run that. So this is what the plot will look like, and then our mean for that is 0.2885, which is consistent with what what the book has. And then show you real quick for 2,000 hours. So this is the plot for the 2,000 hours, and this is our mean here, which is also consistent with the book. And then finally, 4,000 hours. There's a plot, and then here is our mean. And this, again, was consistent with what we had in the book. So this is just a simple Bayesian method, I guess, of estimating probability to failure on a set of data. But that's all we have for today. Thanks for watching.